So dear students, welcome to the 13th lecture of 8051 timer/counter. So this is one more example on timer. Just I will state the question. With a frequency of 22 megahertz, that is with a crystal frequency of 22 megahertz, generate a frequency of 100 kilohertz square wave on pin P2.3. So we need to generate the square wave, and that square wave should have 100 kilohertz frequency. That is what the question is. We need to use timer 1 in mode 1. They are given we have to use timer 1 in mode 1. But the crystal frequency is 22 megahertz. We need to generate 100 kilohertz frequency square wave on this pin. So here I have written the program. It's very simple to write the program. First, as usual, as a practice, we need to give the information about which timer the programmer is using and in which mode we are working. So in the question they have said we have to use timer 1 in mode 1. Give that information in T mode. You will get the T mode value 10H, that is given to T mode. Next we need to load the initial count value. How this initial count value is loaded with respect to this statement now, right? So the crystal frequency is 22 megahertz. We need to generate 100 kilohertz frequency of square wave on P2.5. I will tell you how to calculate the initial count value for this particular statement. Okay, after loading the initial count value, start the timer. In order to start, we are using set B TR1. Since we are using only timer 1, we need to take the timer on 1 bit. Start the timer. So when the timer has been reached to the final extent, TF value becomes equal to 1, then stop the timer. Then complement the value of, in order to generate the square wave, just by only one statement. We are writing CPL P2.3. Next, clear a TF flag. Okay. Then jump back. So back is given, again the count value is initialized. Start the timer, check the TF, CLR, that is stop the timer, complement the value of 2.3, clear, TF, jump back. So this process is to be continuously carried out so that I will get the square wave on P2.3, which is of 100 kilohertz frequency. Now the thing is, we need to give the initial count in such a way that the square wave should have 100 kilohertz frequency. So for that they have given the crystal frequency, that is 22 megahertz. So as a practice, take 1 by 12th of, now the frequency is 22 megahertz. 22 megahertz. So you will get one value, right here. You will get one value. Okay. So take 1 by that value. You will get 1 by that value. You will get 0.546 microseconds, right? So keep this in mind. Okay, keep this in mind. Now we have to create a frequency of 100 kilohertz for that particular square wave. 100 kilohertz, right? Frequency they have given is 100 kilohertz, right? So take the time period of that. T is equal to 1 divided by F. Okay, 1 divided by 100 kilohertz is equal to what you will get. I hope you will get 0.01 milliseconds. Am I right? So convert that 0.01 milliseconds to microseconds. You will get 10 microseconds. So this is whole T. For one pulse, PULSE, sorry, for one pulse, this 10 microseconds is to be divided by 2. You will get 5 microseconds. Okay, 5 microseconds. So this 5 microseconds is to be divided by this value, that is 0.546. 0.546 microseconds. You will get I hope 9 9 cycles. Okay, after getting this 9 cycles, this is to be subtracted from the maximum value of a timer 1 in mode 1. So the maximum value that mode 1 can take is 65,536 minus this 9. 9 is equal to, what you will get? 65 527, right? You will get this much. So convert this to hexa value, double F F7H, double F F7H. So this is the value. This is lower bit, this is higher but 0F7. 0F7 is written here, 0F7H, and FF is written here, 0 double F. 0 is written because the first is a letter, right? Now the program is fully completed. So this program will tells us that we are generating the square wave of 100 kilohertz frequency on P2.3. So hope this program is clear. If you have any questions, you can comment and I will try to answer. Thank you.